Ever wondered how the sleek laptop you rely on every day comes to life? Join us as we unveil the incredible journey of laptop manufacturing, from raw materials to the sophisticated devices at our fingertips. Discover the intricate processes of motherboard assembly, injection molding, die casting, and more as we lift the lid on the engineering marvels behind modern laptops. Stay tuned to see how precision, innovation, and meticulous craftsmanship come together to create the laptops we can't live without. Personal computers first became available in the early 1970s, and it took a little while for electronics designers to start dreaming about making these devices portable. Could the technology of a desktop computer fit into a smaller, lighter, portable device? The answer was yes, but it took several years of innovation and trial and error. The Osborne 1, often considered the first genuinely portable computer, or luggable, weighed in at 11 kilos and featured a 5-inch screen, 2 floppy disk drives, and a variety of software applications, all for what would be around $5,000 in today's money. This revolutionary device allowed corporate executives to carry their data with them, paving the way for the ultra-fast, lightweight laptops we rely on today. However, despite its innovations, the Osborne 1 never gained mainstream success, and the company eventually faded away. Over the next 2 decades, numerous computer companies introduced their versions of portable computers. Each new model brought improvements in memory, processing power, applications, screen size, battery life, connectivity options, and more. By the late 1990s and early 2000s, laptops had become mainstream, indispensable tools for both business and personal use. Today, laptops are marvels of engineering, offering high-speed performance, stunning graphics, and seamless connectivity in a compact and portable package. But how exactly are these sophisticated machines made? Let's lift the lid on the manufacturing process and see how it all comes together. The journey of a laptop starts with its brain, the motherboard. This critical component begins as a printed circuit board, PCB, featuring patterns of lines, pads, and copper traces. Robotic arms apply solder to the board in precise locations, preparing it for the addition of various components. Next, a computer takes high-resolution images of the motherboard to inspect for any missing solder or misalignment. If the board passes this computerized inspection, it moves through up to 15 individual stages where robots place up to 150 components at each stage. These components include everything from microprocessors and memory chips to capacitors and resistors. The final stage of motherboard assembly involves passing the board through an oven, which melts the solder paste and firmly attaches the components to the board. Once again, the motherboard is photographed and inspected to ensure everything is correctly in place. If it passes this rigorous quality check, it's set aside until it's ready to be installed on the laptop. The top half of the laptop, known as the panel kit, is another crucial element in the manufacturing process. This part houses the screen, webcam, microphone, and various antennas. The process starts by placing a protective film over the LCD screen. This screen is then connected to the motherboard via a cable. The screen assembly is placed into a frame that already contains the embedded microphone and webcam. An antenna cover is attached, and the necessary cables and connectors are installed. Finally, the 2 hinges that will connect the panel kit to the bottom half of the laptop are screwed into place, and a thin metal frame is pressed around the screen to secure it. With the panel kit complete, it's time to turn our attention to the bottom half of the laptop, where the motherboard and other vital components will be installed. The first step in assembling the bottom half is to attach the top cover to the panel kit hinges along with the touchpad. Next, the left and right speakers are installed into the top cover. Now it's time for the motherboard. High-powered fans are attached to the motherboard to prevent overheating. After ensuring all screws are properly tightened, the motherboard is attached to the top cover. Even the smallest speck of dust can impede the laptop's performance, so the internal components are meticulously cleaned by hand using delicate brushes and compressed air. Once the internal components are clean, the Wi-Fi and Bluetooth modules are installed, followed by the solid-state drive, SSD, which will store all the computer's data. The final major component to be installed is the battery. Modern laptops require batteries that can power ultra-fast processors, fans, and high-end graphics cards, all while maintaining a long battery life. With the internal components in place, the next step is to attach the keyboard. The keyboard is fitted into an opening in the top cover of the bottom half, completing the assembly of the main body of the laptop. The laptop is now almost ready, but it's not quite finished yet. The final production stage involves a laser etching of the required logos, model and batch numbers, and manufacturer information onto the back of the machine. This ensures that every laptop is correctly identified and branded. Once the laptop is fully assembled, it undergoes a series of automated tests to ensure everything functions as it should. These tests simulate user interactions, checking the screen, keyboard, color displays, and overall system performance. Only after passing these rigorous tests is the laptop deemed ready for shipping. The final step is packaging the laptop, ready to be shipped either to a retail store or directly to the end user. And there you have it, the incredible journey of how laptops are made, from raw materials to the sophisticated devices we use every day. But the story doesn't end here. Let's take a closer look at the various materials and manufacturing processes that go into making the structural parts of a laptop. These parts can be made from a range of materials, including metals and non-metals, each chosen for its specific properties and suitability for different design requirements. One of the most common methods for creating plastic structural parts is injection molding. This process involves adding granular or powdered plastic raw materials into a hopper where they are heated and melted into a fluid state. Driven by a screw or piston, this fluid plastic is then injected into a mold cavity where it cools and hardens into the desired shape. Injection molding is ideal for mass-producing parts with complex shapes and precise dimensions. It offers high production efficiency and stable product quality, although the equipment and mold costs can be quite high, making it less suitable for low-volume production. For metal parts, the stamping process is commonly used. Stamping involves using molds and presses to apply pressure to metal sheets, causing them to deform or separate into the desired shapes. This method is highly efficient and suitable for producing parts with high dimensional accuracy. Stamping can be done at room temperature, known as cold stamping, or at elevated temperatures, known as hot stamping. Each method, cold stamping, is more common for thin metal sheets and offers good surface quality, while hot stamping is used for thicker materials and can improve plasticity and reduce deformation resistance. Another important process for metal parts is die casting. This method involves forcing molten metal into a mold cavity under high pressure, allowing it to cool and solidify into a precise shape. Die casting is known for producing parts with excellent wear resistance, high strength, and complex structures with high dimensional accuracy. In the laptop manufacturing industry, magnesium alloy die casting is often used to create lightweight, thin-walled structural parts. These parts are then treated with surface finishes like spraying to enhance their durability and appearance. The process of manufacturing a laptop is a remarkable blend of precision engineering, advanced technology, and meticulous craftsmanship. From the initial concept to the final product, every step is designed to ensure the highest quality and performance. Now that we've covered the injection molding and stamping processes, let's delve into another critical aspect of laptop manufacturing: the materials used for these structural parts. Laptops can be made from various materials, each chosen for its unique properties, ensuring the final product is both durable and lightweight. One commonly used material in the manufacturing of laptop structural parts is a blend of polycarbonate and acrylonitrile butadiene styrene, known as PCABS. This plastic material is favored for its excellent balance of strength and flexibility, making it ideal for parts that need to withstand frequent handling and impact. Additionally, PCABS is easily molded into complex shapes, allowing for innovative design solutions. For higher-end laptops, manufacturers often turn to metals like aluminum and magnesium alloys. These materials offer superior strength-to-weight ratios and an elegant finish that enhances the overall aesthetic of the laptop. Aluminum, in particular, is used extensively in premium laptop models due to its excellent thermal conductivity and ability to be anodized for additional corrosion resistance and a sleek appearance. Magnesium alloy is another metal frequently used in laptop construction. Known for being even lighter than aluminum, magnesium alloys provide excellent structural integrity while keeping the overall weight of the laptop to a minimum. However, working with magnesium alloys requires specialized techniques such as warm stamping due to their lower ductility at room temperature. The choice of material not only impacts the laptop's durability and weight, but also its thermal performance. Metals like aluminum and magnesium are particularly effective at dissipating heat, which is crucial for maintaining optimal performance and longevity of the internal components. As technology advances, so do the manufacturing techniques used to produce laptop components. One such technique is CNC, computer numerical control machining, which is employed to create highly precise and intricate parts. CNC machining uses computer-controlled tools to remove material from a solid block or billet of metal or plastic, achieving exact specifications and fine details that are difficult to obtain with other methods. Another cutting-edge technology making waves in laptop manufacturing is 3D printing. This additive manufacturing process builds components layer by layer from a digital model. While 3D printing is not yet used for the mass production of laptops, it plays a significant role in prototyping and creating custom parts. This flexibility allows designers to quickly iterate and test new ideas without the need for expensive and time-consuming tooling changes. Both CNC machining and 3D printing offer unique advantages that complement traditional manufacturing processes. CNC machining provides unmatched precision and repeatability essential for producing components that meet stringent quality standards. On the other hand, 3D printing offers rapid prototyping capabilities and the ability to create complex geometries that would be impossible or cost prohibitive with conventional methods. Witness the incredible journey of laptop manufacturing from raw materials to a sophisticated device. Subscribe for more tech insights.